Okay, assess for chapter 2 for the foundation course, working on page 31, 32, 33, 34, might take a couple of videos over this. Question 3, this is at the top, it says work out the size of each of the angles marked. Well, I've got 146 there, and vertically opposite to that I've got angle A, so that makes that 146 degrees as well. That's a straight line, A and B add up to 180, so the leftovers for that one's going to be 180, take away your 146, and that will give me 34 degrees. Easy peasy. Here we have angles at a point, all adds up to 360, so merely take away these three angles. Of course that's a 90-degree angle, isn't it? Take these three away from 360, and let's just do that. So it'll be 360 take away, let me just add up that little lot there for you. So I've got 50 plus the 90 plus the 65. So on block I'll take away 205 as one big block of angles, that's those three, and angle C is therefore going to be that minus that. That leaves you with 155 degrees. Now, this is a real beautiful question, this. Look, these three plus the extra little bit here, the 96, comes 180. So basically 3Ds is going to be 180 take away the 96. That leaves me with 84 degrees, so a single D is going to be 84 over 3. That's going to be something special. Let me have a look. 84 divided by 3, each D is worth 28 degrees. Lovely. Now, is ABC a straight line? This is question 4. Don't know yet. However, if these add up to 180 degrees, then it's a straight line. Let's just try it then. 35 plus 75, this is me showing my working, equals, here I go. So 35 add 75 add 80 comes to 190 degrees. Therefore ABC is not a straight line because the angles must add up to 180 degrees, and then you're giving your reason for that, which is really good. Alright, so that's how you do it. Next little bit, this is question 9 on the bottom page 32, grade D. Work out the size of the angles and give your reasons. Okay, fine. Well, listen to me talk then. A is 72, Y, come on, you know what it is, corresponding angle. And what's B going to be? That's going to be 180 take away 72, because it's angles on a straight line add up to 180, so we're left with 108 degrees. Done. Right, angle C. I'm not sure I want to do this. Yeah, let's just do that. This angle here is vertically opposite the 105 there, so that makes it 105, and this 105 is corresponding to the angle C, so angle C is 105 degrees as well. Again, listen to what I said in terms of the reason. And what should we do with this one? 112, okay, on the other side of the line, on a straight line, we take this away from 180, and so I've got 180 take away 112, gives me 68 degrees, and therefore angle D is corresponding to the 68 degrees calculated, so angle D is also 68 degrees. Now this one is a very nasty piece of work. Let's just change that bit to red. Now look, parallel line, horrible, horrible, horrible arrangement. Watch this. I've just shoved an extra parallel line in there to help you see the problem. I'm even going to put an arrow on it. Now look at it very carefully. If these three lines are parallel and my red parallel line cuts through that point right there where I'm highlighting with my pen, then I reckon this part has got to be 65 degrees, because I've now created an alternate angle. If that's 65 degrees, then this little part must also represent angle E, because angle E is alternate to the angle E shown there. Simple enough? So E there and E there are alternate angles. So how do I find that little slice of E? Very simple. I've got 83 degrees, the entire angle in the question. Take away the 65. That should leave me with 18 degrees. So angle E is going to be 18 degrees. Okay, I'll let you think about that one. Now let's see if I've got time to do the next little bit. I might just do another video. No, I'll do this one and then stop. Right, show that, this is question 12, show that line XA is parallel to BC. So in other words, that one's parallel to that. They want me to prove that this is true. Okay, fine, I've got 30 degrees inside triangle ABC and it's definitely isosceles. So here I go. Let's do some calculations down here. Here we go. Let's do it this way. Angle ABC is going to be 180, take away the 30, and then divide it by 2. Is that alright? So that's the same as that one. So let's just do a calculation. That'll be 150 divided by 2. That gives me 75 degrees. What's the big deal? Well, I'll tell you in a minute. I've just proven that's yellow, please. Red, please, rather. I've just proven that's 75 degrees. If this is 75 degrees and angle XAB is also 75 degrees, they are therefore alternate angles, making XA and BC parallel lines. So let me just write that up a little bit so it stands out to kind of get my grade C. Right, so I've proven that angle's 75 degrees, and I'm now going to say angle XAB equals angle ABC. Therefore, they are alternate angles Therefore, XA and BC must be parallel. Okay, and I'm going to stop it there and look at some of the questions, the AQA questions in the assess right now. A couple of AQA exam style questions on page 33/34. This is actually question 3 on page 34, so we'll do it together now and pretend we're in an exam, shall we? AB is parallel to CD, obviously, because the arrows give the game away. Write down the value of X, very simple, 128 degrees, you know this by now, because they are corresponding angles. Work out the value Y. Fine, I think I will. Loads of ways of doing it. I know that 85 would give me a leftover of 95 degrees because of angles on a straight line. If that's 95, then Y is also 95 degrees because I've proven that this 95 and that Y are alternate angles, and so therefore Y and the 95 shown are the same. That's that one done, and that's my reasoning behind that. And here's the last question. I rather like this one, it's very creative. Rebecca has 3 rectangular sheets of paper, bless her. She cuts each sheet into 2 pieces. So now I've got 3 bits of paper, 6 little halves, that's the story. She has 6 pieces, A to F as shown below. Which piece is part of the same rectangle as A? Right, they all look like they're going to fit beautifully, don't they? But they're so not. Now, the answer is E. E and A go together, and I'll show you why. If you imagine E fits right here, again I'll probably rub it out later. Imagine that slice E, and I'm going to put in your 50 degrees right there. Do you see these two 50-degree angles are now alternate angles, which means E must have been part of paper A, which makes part of the oval rectangle made of A plus E. Right, so there you go. The two 50s are alternate angles, and therefore it must be an identical fit. Right, that's that one done. Better change colour. Now, what about B then? I don't know. Let's just study these things. I reckon C and B go together. I've got to try and draw you a little picture here. So I'm going to take my B, spin it around, and stick it against the end of C. It's going to look a little bit like this. It's quite hard to draw. So imagine my B is not there anymore, and I've stuck it right there, and this fits into this exactly. So look, if that's my 55, and these are my two 90-degree angles. Look, 55 plus 125 comes to 180 degrees. They formed a straight line, so therefore B and C go together, and I'm left therefore with D and F, for which I'll be working in green. D and F have to go together, no thoughts there. So I've done that, and I've done those two bits. Now, because D and F are leftovers, I can use it to work out mystery angle X on piece D. So essentially, I'm going to take my F and take it over there and finish off my little rectangle as shown. If I stick it upside down, I've got my two right angles there, and I've got 115 degrees there shown in green. Doesn't show very well, does it? But anyway, there's 115 degrees. Now the 115 degrees plus my X comes to 180 degrees altogether. So therefore X is going to be 180, take away the 115 degrees inherited from shape F. That will give me 65 degrees for angle F alone. And I think I'll stop there as a mini assess, and that's unit 2 over for foundation level unit 3. Thank you for watching. Time to go and study.